So for section 12.5, we're still looking at right triangles, and they're going to give you word problems. So the word problems are basically going to describe a scenario for you, and you'll be able to set up a right triangle, label as much as you can based on whatever information they give you, and try and figure out where the right angle's at. The other two angles should be your acute, and then you solve completely by getting all three angles, all three sides, okay? So the first one we're going to do is we're going to say how far above the ground is the kite. Okay. If it has an angle of 38.2 degrees and the string is 70.8 feet. Okay, so think of your person standing right here. Here's your person, and they've got this kite in their hand, right? Going up, and then your kite's up here. Here's your kite. Here's the little tail for the kite. And that creates a right triangle, right? If you go straight down from the kite, that's where your 90-degree angle's at. And then this acute angle right here from the person up to the kite is 38.2 degrees. And the string is 70.8 feet. They want to know how far above the ground is that kite. So from here straight up, we'll call that side X. Okay. Right, so from here, from this angle right here, this is the opposite. This is the hypotenuse. So we're going to use what? Sine. We're going to say the sine of 38.2 degrees is equal to the opposite, which we'll call X, over the hypotenuse, which is 70.8. And we want to solve for X. Right now it's being divided by 70.8, so we multiply both sides by 70.8. So here we cancel. We've got X is equal to 70.8 times the sine of 38.2. Punch it in the calculator, and I got roughly, got to round it, I got 43.78. Anybody want me to show how to punch that in the calculator? You guys got that part down, I assume at this point? We'll call it 43.78 feet. Okay, so that one only asked for that height. Could have also asked for the distance from the person to there. Could have also asked for this angle. If it asks you completely solve it, then completely solve it. But in this case, it only asked for that, how high it was above from the ground. Any questions on example number 1? All right, example number 2. We've got a 30-foot ladder. It's leaning against the wall. We want to know leaning on the wall, and it's 9 feet from the bottom of the wall. What is the angle of elevation? So, you know, when you go to Home Depot, you can buy ladders of different lengths. So you can buy like a 9-foot ladder, you can buy a 20-foot ladder, you can buy a 30-foot ladder. So you generally know how tall your ladder is, but if you lean it against the wall, so here's your ladder, okay, here's the side of your building, and that creates a 90-degree angle, right? That ladder is 30 foot. I know I'm quite the artist, right? Yeah, that's super fancy. And from the bottom, from right here to here is 9 feet. We want to know this angle right in here, question mark. You can call it X, angle X. You can call it one of those Greek letters, alpha, beta, any whatever, okay? But we need to know which trig function we're going to use from that angle. So I'm going to call it X. So 9 feet is opposite, adjacent, or hypotenuse? Adjacent. The 30-foot ladder is the what? Hypotenuse. So which trig function is going to be used here? Cosine. So we're going to say the cosine of X, let's call it a Greek letter, let's call it alpha, is equal to the adjacent, which is 9, over the hypotenuse, which is 30. We're solving for an angle, so do we use regular or inverse trig? Inverse trig, so we say inverse cosine of 9 over 30. That's going to give us that angle alpha. So punch it in the calculator. There we go. Inverse cosine. Make sure it has, just shows the little symbol up there. And then 9 over 30. I got 72.5. You want to round it to the nearest whole number or the nearest 10? Nearest 10. So let's go 72.5. Okay. At this point, you could calculate this angle, and you could do the Pythagorean theorem to get this third side. Just depends what they ask you. They might ask you to completely solve it, or they just might ask you for one of the missing pieces of information.